Hi guys, I'm Braidon. I'm working at a company called Super API with Riley and Sam over at the back there. So, come say hi after this. And today, I'm just going to sort of talk you through a new sort of technology in the Elixir space called Flame. And kind of give you a bit of an idea about how you might go about using it and what it's good for, and maybe what it's not so great for, and some of the pitfalls that you might come across if you want to give it a try. I meant to say as well, like if you have questions and things like that, just stop me and I'll do my best to answer it. But if we're going to come back and revisit, I might just sort of park it for the time being. All right, so bit of an intro to Flame. It was developed by a guy called Chris McCord, who's basically the creator of a library called Phoenix, which, I guess a lot of people that use Elixir have come across Phoenix. And he's basically written this tool to help you elastically scale your application across multiple machines. And I'll get into a little bit about exactly what that is and how that works. At the moment, it's predominantly, or it's shipped with a backend for Fly.io, which is a hosting provider. Chris works at Fly.io. I think there's also a community-driven, community-developed K8 backend for Flame. But I guess theoretically, this is something that can be ported to pretty much any kind of hosting provider. Like, I know there's talk of doing an ECS backend for this, and conceptually you could do the same sort of thing for like GCP and for Azure. So it's fairly sort of generic. And I guess the other cool part of this is it also kind of allows for local testing. So even though prod, you're doing all this stuff with different machines and things like that, locally you can kind of still test it on your own machine. Rather than kind of just go through the docs, I guess, around how this works and what you do, I thought I'd sort of take you through sort of a fast-forward process of building an app, and building an app that can kind of make particular use of something like Flame. We can kind of go through some of the problems that you might encounter when you bring Flame into it and how that would help solve some of the problems that you're going to come across. So the app that we're going to be kind of walking through is like a website auditing tool. So it's going to make use of something called Google Lighthouse, which is a technology developed by Google. And basically the idea is you're going to get users are going to come into your application. They're going to sort of enter a website that they want to check. We're going to run off and we're going to run a Lighthouse audit against their website, process some results, and then give that back to the user. Okay. And I guess the context for this is we've kind of got an MVP of this kind of working and it's kind of running, but it's a pretty early stage product. Just a little bit of a quick aside about Lighthouse. So Lighthouse is, as I said, developed by Google. It's actually shipped with Chrome. I'm not sure how a lot of people probably know what it is, but for anyone that doesn't, it's basically a way to profile a website, how quickly it loads, does it follow like SEO best practices and accessibility best practices and things like that. It comes with in Chrome, so you can run it locally. But crucially, I guess it also comes as an NPM package, so you can go and download, the Lighthouse NPM package and run that programmatically against whatever website you want. Okay, so basically, as I kind of said, where we're up to with this app, I guess, is we've got like what I call like a naive implementation done. So we've got it set up that we can take users and they can put in a website. On the back end, basically what we're doing is calling system.cmd, which is basically going to run a process on a machine. that's going to go off and run Lighthouse against the website that they set up. There's a bit of stuff in here about setting up the arguments and stuff for that. That's probably unnecessary detail. I guess the main point is that this is running all on that one machine that we've got running the app. This works really well. This is probably how you go about doing it if you were doing this for real to start with. I think the problem that you're going to come up to pretty quickly is, once you start doing a hacker news posts and things like that, it gets a bit of traction. You're going to start to have some problems. Namely, your computer is probably going to explode because Lighthouse takes maybe 10 seconds to run for a website, give or take a couple seconds. So very quickly that web server is just not going to be able to deal with all of the traffic that you're getting. That's, the obvious, I guess, question here is, well, can't we just spin up more web servers? Like if this is the bottleneck, we just make more of them, and that will kind of work. It's not a great solution because Lighthouse is quite CPU intensive, and it only needs to kind of run when people are actually using the site. Whereas like your web app is pretty basic. It doesn't need to do a whole lot of stuff. You can probably get away with a pretty small machine. It's just really those sort of spikes in traffic that are causing us problems at the moment. If we start sort of duplicating our web servers and creating 20 of them and having that all there, this whole project is going to become pretty much unviable, right? It's just going to cost way too much. And there's a better way of doing it. So really what we want to be able to do is when people are coming in, we get a whole bunch of traffic, 10 o'clock in the morning, everyone's had their morning coffee, they all come in, they want to check their site. We really want to just sort of spin up on the fly some more machines that can kind of handle the traffic, deal with that, and then sort of let that scale back down to zero. One of the ways that people that are kind of familiar with Elixir will deal with problems kind of like this is some of the Beam primitives that kind of ship with the Beam, things like task.async, also things like the OBAN job processing library. These are both really, really good tools. And I guess if people are kind of newer developers, they're kind of new to the language, these might be the kinds of tools that they come across and they might be able to help them solve these types of problems. The problem with this is that this Lighthouse thing that we're running is kind of running outside the Beam. It's like a OS process that's running. And these tools work kind of exclusively with things that are running inside the Beam, the Elixir virtual machine, right? And so these are really going to do nothing to kind of help this sort of issue. Probably what the standard kind of thing you come up with is something kind of like this, some sort of serverless architecture. This is a version that I kind of came up with, but the idea is that when people come in and they submit a website that they want to check, we're going to push that off to some job queue somewhere. We're going to have a bunch of like job processing, Lambda functions, something like that, that are going to take those jobs and run Lighthouse and calculate results and then stick that back onto like a results queue. And then our application is going to grab those and process them into some sort of usable format, save that into a database, and then give the results back to our users. And I guess this is kind of a generic solution to this kind of problem, but it's got a couple issues. First is, it's kind of complicated. If this is like a little side project or a little work project or something, now this is getting quite complex, and I've got to deal with 3 or 4 different services, and I've got to serialize data between my app and the job queues and deserialize it on the way back in. And I've got 4 different services now. I've got to monitor and check and debug and all that kind of stuff. And so that's a kind of a big trade-off that I have to make. The other thing is that you're kind of throwing away a lot of the benefits of Elixir if you get on this path. Like, we kind of gravitate to something like Elixir because, you know, it can, you get a single code base, you get a single app that you can deploy, and it kind of just runs, and, you know, we can test it locally with a lot of, without too much of a hassle, and it's easy to debug and easy to make progress, you know, add features and stuff like that. It's also like really robust and tolerant. And if we go down a path like this, you kind of, you can do all of that stuff and you can get it to work. But yeah, all of that whole job processing piece is going to all be done outside of Elixir, and you're going to lose a lot of the benefits. And it's not to say that this won't work, but you know, I think there's a better way to do it. And this is, you know, a surprise where Flame comes into play. This is kind of how you refactor that earlier sort of process with Flame. It's really quite simple. You basically add a mixed dependency and a little bit of config, and then you can basically sort of wrap a function in this like flame.call. That's like basically all you need to do to get it to actually work, assuming you've got a backend that's all up and running. That's like obviously a really simple version of this, and doesn't really explain what's going on. So I'll kind of take you through what's happening when we actually do that flame.call piece. So this all kind of whole piece relies on some of the Beam clustering processes, and I'll kind of talk you through it. But if you've got questions on how this all works, like, feel free to stop me, and you know, we can kind of talk through it. Basically, what happens when we do that flame.call is our app is going to send a message to our backend's hosting provider. This could be like Fly.io, it could be Kubernetes, it could be CS, something like that. And it's going to say, here's a spec. I want you to give me a new machine that's running my application with these specs. Once that new machine has been provisioned, it's going to call back to our app, and it's going to connect to our app as a Beam sort of child node. So you're going to basically be running in like a clustered Beam system. Once we've got that connection established between the child and our app, we're going to send it basically the closure to the child. So that closure will include basically all of the variables that you need to run that closure. Remember that this child app is actually running a copy of our application, so we don't need to give it like the bytecode or anything that it needs to run. It's already got all that stuff. All it needs is the actual values that are going to be required. It's going to run that closure for us on the child. And once it's finished, it's going to basically send us the results back to our parent. And then we've got the results. That child is then going to basically terminate. So it's going to go away. There's a little bit of nuance here. Like, sometimes children can basically stay alive for a time. That can all be configured. You can configure how quickly they'll scale down and things like that. But for all intents and purposes, it's going to spin up a new machine. It's going to run that closure for you, and then give you the results back, and then sort of go away. What that's going to look like is kind of here. So you're basically going to have, under the original model that we had, you're going to have one machine running our app, and you're going to have a bunch of node processes running for Lighthouse jobs for us. Under this new Flame model, again, we're going to have this one server running our app, but that could be a pretty lightweight server. It's going to deal with web traffic. And then we're going to have these Flame runners, or these child child nodes. Each one of those nodes is going to be running a copy of our application, and it's also going to be running as many of those node processes as we can fit onto one of those machines. And again, all of that stuff can be configured. We can how many concurrent processes, how many concurrent jobs you want to have, how big the pool is going to be, all that kind of stuff can be configured. So yeah, that's kind of basic structure. Does that kind of make sense to everybody so far? Are you all kind of following? Cool. Okay. So just to kind of go through this a little bit. Basically, what this is doing is it's kind of doing away with a whole bunch of problems that we had with the earlier architecture. I kind of said this before, but it's basically, keep in mind, this is running a complete copy of your full application. So you can do stuff like insert records into your database. You can broadcast over pub/sub channels. You can do all that kind of stuff from the child nodes. You don't have to serialize and deserialize stuff between children and the parent. So you just don't have to deal with any of those issues. This is running a copy of your application. So all of that stuff will just work. You don't need to worry about separate infrastructure. You don't need to worry about all that separate stuff that you're going to have to deal with if you go down the path of having job queues and processes and things like that. On that note of dealing with running a copy of your application, I just wanted to call out that there's a way within Flame to basically choose which parts of your application are actually going to run on those child nodes. The reason that's important is, if you've got a child node that's running some Lighthouse processes, for instance, you probably don't need to run like a Phoenix endpoint. You probably don't need to accept web traffic. You probably don't want to have a OBAN job runner on that server. So you can actually basically tell your application, if you're running inside one of these Flame children, just start these pieces of your app and don't stop the rest. And that way you kind of can define the kinds of functionality that's actually going to run on that child process. And there's also some config that you can do, I guess, as well. So things like limiting your database pool size if you're running in Flame to like 1 or something, so you don't have to overload the DB if you've got a huge number of these things running. Okay, so that's kind of how Flame would work, and I guess in the context of what we sort of talked about, it would kind of solve that immediate problem that we had. And you kind of, let's consider now we've gone ahead, we've put Flame in, it's all working, and everything's running really smoothly. As we're going about building our little website auditing app, though, we might run into another problem, which is that sometimes these Lighthouse reports that we're generating kind of look a bit weird. Like performance of the server is just like really bad for some reason. We don't really know why. Customers are kind of complaining about it a little bit. We give them a bad score, but actually their app is running really nicely. And there's a couple of reasons that might happen. Maybe you just get some packets dropped. Maybe you're hitting a cold server and it needs a bit of time to start up and warm up. But basically the solution to that sort of problem is to run these Lighthouse jobs 3 times. And it's when you run it 3 times, you can then sort of pick the middle one, basically, which is what you do. So you run it 3 times, discard the best performing report, discard the worst, keep the middle. The way we've got this set up at the moment, though, is we're basically just treating this like a gen server call, almost like we're doing this remote sort of function call. It's running and coming back, and if you want to do it 3 times, there's probably a little bit more structure we need to put around doing that. We need to make sure we've actually called it 3 times and manage that state somewhere, and there's a little bit that's gotta go into that. If we weren't using Flame, we'd probably do something like a gen server to handle this. So we build a gen server for each website we want to audit. That would kind of have a bit of stake in there around how many times we've done an audit for that site. Once we've done 3, it'll do some processing and give us back the results and then sort of terminate. It doesn't really work with Flame because the way we want to do it is we kind of want these to run back to back. We guarantee that they're going to run back to back as one sort of cohesive unit. It doesn't really help us if we run it once and then we wait 20 seconds and we run it again because the server might have had a problem or something like that. And what we want to do is run 3 back to back and then process the results. The way we kind of deal with that with Flame is this thing called place child, and this is kind of the next sort of thing that it can do. And what this does is it actually, instead of before we were sort of sending a closure, saying here's some data, this function, go process and give you back the results. What this lets us do is actually spawn a child process on that Flame machine that's going to go off and run. They're going to get monitored by the parent, sort of in the same way that you would, supervisor.startChild or something like that. You can start a monitored, supervised task on that Flame machine, and kind of keep all of the benefits that you get. You can restart it if it fails. You get the results back. It's all monitored and supervised. So obviously that's kind of a great fit for what we were talking about. What we do is we go ahead and do that Gen server implementation that we talked about, but rather running it on our parent application and then calling Flame every time we do a Lighthouse report, we basically spawn that Gen server process itself on the Flame machine and let it run, do the 3 Lighthouse reports, do the data analysis, give us back the results, and then the process would terminate. And we get solid data for our customers. So yeah, to recap kind of how this has all gone, basically we've gone through, we've built this app where people can enter a website into this thing, and we can go and run 3 Lighthouse audits back to back in sequence, grab the data and get the results back. We can do all this cool elastic scaling stuff around, spawning new machines to meet the customer demand that changes throughout the day, but not sort of spinning up 20 new web servers. And we also get to do all of that, kind of keeping all the benefits that we have with Elixir, right? So, where we've got this single code base that we're doing, we've got single deployment. We only need to worry about our app and our database, and you get all that good, process monitoring, process supervision, stuff like that you get with Elixir, but all the benefits of elastically scaling, basically, and running this stuff on a separate machine. And yeah, so I guess that's most of what I've got. I've got a couple links in here, so I'm sure we can get the slides out to everyone after this. Any questions on this stuff? Yeah.
I have a question, but an add-on, which I would just note that if anyone wants to try it on Fly, they won't let you unless your parent application has 8 GB of RAM. Just learn from experience.
Right. Okay. Yeah.
It will error out. So parent does not have enough memory. And I spent enough time in pain with that. So now you all know.
Oh, cool. Any other questions? Anything else from anyone? Yeah, Julie.
So what the poll of runs, does that spin a new one up every time, or does it keep it running? It's all wet today.
No, so to keep it running. So you can configure a pool of, say, 5 runners or something. Each one of those runners can have 5 tasks that it's doing, and then you configure a timeout. So idle for 10 seconds, they'll spin down. I think with Fly, generally, they'll spin up in about 2 or 3 seconds, maybe a little bit longer. So they're pretty quick to spin up, but yeah, you can definitely keep them around.
Yeah, so the problem you're trying to solve here was that you were running a Google Lighthouse Wi-Fi system, right?
Mm-hmm.
What other sorts of problems is Flame good at solving? And where would you just not use a gem server or supervisor or something like that?
So Flame is really good at dealing with like computational bound problems. So things that, I guess, some problems are going to be really sort of IO heavy. You're going to be sending HTTP requests and stuff like that a lot. Elixir is really, really good at that. Things like this, when you're just like running a OS process, you're doing things like AI inference, stuff like that with a model, like with Bumblebee and things like that. Anything that's going to need like a GPU, for instance, you probably don't want to be running that on your web server. So anything where you kind of need to have a bit more computation, stuff that's going to run for kind of a bit longer, or is going to need to run on hardware different to what you need for your web app, that's probably when you go for something like a Flame.